Okay, good morning, class. Right. So today, we continue on 4.3. There is a specific latent heat. Okay. So before I explain more about a specific latent heat, okay. So let's watch this video first.
When a substance changes its state, heat energy is involved. The energy is not to heat up the substance, but to separate the molecules from each other. This is known as specific latent heat. Specific latent heat should not be confused with specific heat capacity. Before watching this video, I recommend watching this one first. Specific latent heat is defined as the amount of heat required to change 1 kilogram of a substance from one physical state to another without any change in temperature. So specific latent heat is the heat energy absorbed or given out when a substance undergoes a state change. For example, the heat energy absorbed when a candle burns and a solid wax melts. Two key things to note. Firstly, that specific latent heat is particular to state changes, so the specific latent heat to change ice to water is different to the specific latent heat to change water to water vapor. And secondly, that there is no change in temperature during the change of state. It remains constant. The temperature will only change once the state change has completed. As I said before, the heat energy is not used to heat up the substance, hence no change in temperature, but instead used to make or break the bonds that hold the molecules together. If we heat up a plastic fork to its melting point, see between points B and C on this graph, the heat energy it absorbs at its melting point is busy breaking the bonds between the individual plastic molecules. Once enough bonds between molecules have been broken, the fork will melt and become liquid plastic. Messy. After this point, if we keep heating up the melted plastic, a temperature rise will be detected. The temperature will keep rising up until the next state change, liquid to gas. At the vaporization point, the plastic would stop increasing in temperature whilst it transitioned to gaseous plastic. Once in the gas state, if we were to continue heating further, the gaseous plastic would, you guessed it, rise in temperature. So breaking bonds is why the temperature does not rise or fall when a substance undergoes a state change. Remember I said earlier that it may take a different amount of heat energy to change a solid into a liquid than to change a liquid into a gas? For example, it takes 7 times more energy to turn liquid water into gaseous water than it does to melt ice into liquid water. This means a substance can have 2 specific latent heats. Now let's have a look at the maths. To calculate specific latent heat, we use this equation. This formula can be rearranged. The units of specific latent heat are joules over kilograms. Let's do a practice problem. Remember that specific latent heat of fusion is the energy required to make water to go to liquid from solid. Pause the video and attempt the problem before pressing play.
Okay, so I start until here, right? So actually, you got the basic idea what is actually the specific latent heat. Okay, so this last week, right, we learned about the specific heat capacity. So the specific heat capacity is the amount of heat energy, right, to increase 1 degree Celsius for 1 kg of substance. So there must be a change in temperature. There must be a rise in temperature for 1 degree Celsius for 1 kg substance. Okay, so that is the specific heat capacity, and there is no phase change. I mean, there is no like solid change to liquid or liquid change to gas. So it will just stay in the same phase. Okay, but for the specific latent heat, right, it's actually the amount of heat energy, okay, that required to change the phase, okay, for 1 kg substance. So let's say, for example, from solid to liquid. So let's say for ice to water. So how much the energy that you need, okay, to change the phase from the from the ice to water, okay, for 1 kg ice. All right. without any change of temperature. Okay, you only need to change the phase. Means you change from solid to liquid or liquid to gas. Okay, so that is basically what is a specific latent heat. So it's different from the specific heat capacity. Specific latent heat, you don't need the temperature will not rise, it will constant. Okay, but for the specific heat capacity, you need to rise 1 degree Celsius for 1 kg of substance. So what is the amount of energy for you to increase the temperature for the substance? So it's a very different thing. Okay, so we will look further about this one. Okay, so for a moment I present this. Okay, specific latent heat. Okay, so what you wish that we learn on 4.3. Okay, so the first one, you have to define what is the specific latent heat of fusion, specific latent heat of vaporization. Okay, and then you have to state the meaning of the specific latent heat of fusion is 3.34 times 10 power of 5. Okay, and then after number 3, you have to state the meaning of the specific latent heat of vaporization of water. There is 2.26 times 10 power of 6. Okay, and then for number 4, you have to know how to use the kinetic theory of matter to explain why the temperature still remain constant. Okay, even though you give the heat to the substance, it will still remain constant. Okay, and why the temperature increases after the ice melts to the water. Right, so we will look one by one. Okay, so this is the ice kacang, right? So let's say for the ice kacang, you live in the room temperature. So what will happen to the ice kacang? The ice kacang will melt, right? So mean there is a phase change here from solid to liquid. Okay, so what changes happen? So this one I already answered just now. It will melt. Okay, and for the, let's say if a fish can be cooked by steaming in a steamer pot, right? So what changes happens to the water in the steamer pot, okay, when it boils? Okay, so what happened here? What happened to the changes to the water? What changes happen to the water in the steamer pot when it boils? What will happen? It will change to liquid to gas, right? So it will be the vaporization. Okay, it will change the phase, right, from the liquid to gas. All right. Okay, so latent heat. So the heat absorbed or the heat release, okay, at constant temperature during change of phase. Okay, so that is the meaning of the latent heat. So how much energy that you need, okay, to change the phase, okay, at the constant temperature. Okay, so let's say for example, start from ice. Okay, so it will melting to liquid. So how much energy that you need to give to the ice so it can melt to liquid? Okay, to melt to water. And then after that, what is the amount of energy, right, that you need to change the liquid here, okay, or water, okay, to change to gas, okay, by the process of evaporation. Okay, so how much energy that you need to give to the water so it can change to gas, okay, but without change in temperature, right? So this is the process of the changing of phase. So let's say for ice to liquid, we call it as a melting. Okay, for liquid to evaporation, for liquid to gas, we call it as a evaporation, and gas to liquid, we call it as a condensation, and liquid to ice, we call it as a freezing. Okay, so here let's say from the ice to the gas, we call it as a sublimation. Okay, and for those who change from ice, they say the melting process and the evaporation process, and also the sublimation process. Okay, you have to remember the heat is absorbed. Okay, so the heat is absorbed here. Okay, but let's say from the process of condensation and freezing and so deposition, so this one is also gas change to the ice or gas change to the solid. Okay, so this one the heat will be released to the environment. Okay, so this one you need to know. All right, so 4 main change of phases. So the first one, solid change to liquid. So this is called as a melting process. So for this one, the latent heat is absorbed. So means the heat is absorbed, okay, to change the solid to liquid. Okay, so that is the melting process. Okay, for liquid to gas, okay, this one call it as a boiling process. Okay, and for this one, the latent heat is absorbed also to change from the liquid to gas, right? And another one, from gas to liquid, we call it as a condensation process. Okay, for this one, the latent heat is released. Okay, and for the liquid to solid, okay, this one is called as a freezing, okay, process. So this one also, the latent heat will release. So this is the four main changes of phase, and what process does involve, okay, in the change of phase. Okay, so let's say for solid liquid, we call it as a process of melting. Okay, and liquid to gas is a process of boiling, and the gas to liquid, we call it as a process of condensation, and liquid to solid, we call it as a process of freezing. Right? Okay, for this activity, so this one is to study the change in temperature, okay, when the heat is supplied to a solid at its melting point. Okay, so for this one, you have to heat the ice in a beaker slowly. Okay, so does the thermometer reading increases? Anyone? Does it increase? Yes. No. Okay, at the first time, before it start to melting, the temperature will still remain the same at first. Okay, because there is a change of phase there, right, from solid to liquid. Okay, and then the first one, the second one, what is the effect of the heat supplied to the ice? Okay, so for this one, the heat is absorbed by the ice to use to break up the bond between the molecules. So as you know, this is a form of solid, and the solid is actually, you see the distance, right, between the molecule in solid is very close, right? So if you want to make it to liquid, right, you know the liquid, there are distance is like not like quite further, okay, from each other. So they need to break a bond, okay, between this molecule. So they need energy to break the bond. So that's why the temperature remains the same, because the energy is used to break the bond so it can move freely, okay, like in the liquid state. Okay, so the heat absorbed by the ice is used to break up the bond between the molecule, right? So what happened to the temperature when ice melts? Okay, so the temperature will remain the same, okay, until it's melting. Okay, so the heat absorbed by the ice is used to break up the bond between the molecule, right? And then there is no increase in the kinetic energy of the ice molecule. So means there will be no increase of speed, okay, for the movement of ice molecule, because all the energy that being used, okay, is used to break up the bonds, okay, between the molecule. Okay, so the temperature remains the same when ice change to water. Okay, for this one, okay, heat the water in a beaker. What is the effect of the heat of water? So the temperature will increase. Okay, and then after that, you continue to heat even though the water in the beaker is started to boil. Okay, so what happened to is the temperature rise up? So of course no. Okay, because this one, they need the energy to break the bond to change from the to the liquid to the gas form. Okay, so if not, what is the effect of the heat supplied to the boiling water? Is used to break up the bond between the water molecules, and the water will change to steam. Okay, so name the heat absorbed or given out, okay, at the constant temperature during change of phase. For this one is actually from liquid to gas. Okay, so this one we call it as the latent heat of the vaporization. Okay, so for just now, Remember for this one, right? Okay. So for this one, this is from solid to liquid, right? Solid to liquid. So the heat energy that need to change the solid to liquid, we call it as the latent heat of fusion. Okay, or liquid to solid also we call it as the latent heat of fusion. Okay, so the amount of heat energy that need to change the solid to liquid or liquid to solid, okay, we call it as the latent heat of fusion. Okay, all right, and then they say for the gas, for the liquid to gas. Okay, for the liquid to gas, we call it as a latent of heat vaporization, or gas to liquid also we call it as a latent heat of vaporization. So both same. Okay, so this is the two types of the latent heat. Okay, so latent heat got two types. Latent heat got two types of latent heat. The first one is a fusion. Okay, this one is to the change to solid from to liquid. Okay, and the other one is vaporization. This one is to change liquid to gas. Okay, and also this one also liquid to solid, and this one also gas to liquid. Okay, so there are two types of latent heat, so you have to know to differentiate between both. Okay, all right, so define the latent heat. All right, so we have to define the latent heat. So the heat absorbed or released at constant temperature during change of phase of substance. Okay, so this one we already discussed just now. Okay, so what is the latent heat? Latent heat is the heat absorbed, okay, or released, okay, at the constant temperature during a change of phase of a substance. Or you can say the amount of heat energy, okay, needed to change the phase, okay, of a substance without any change in temperature. Also can, okay, but you must have the keyword there, must have the constant temperature, okay, and the change of phase there. Okay, so this is the change of phase there. So solid with liquid, we call it as a fusion, okay, and liquid to gas, we call it as a vaporization, okay, and then gas to liquid, we call it a latent heat of vaporization, same, okay, and for the liquid to solid, we call it also latent heat of fusion. Okay, just the difference is one is the heat is absorbed, and another one the heat is released. Okay, so that is the difference. Okay, all right, so why can I ask you some questions? So why does the energy what happened to the energy? Okay, okay, sorry, let's say from gas to liquid, right? Okay, gas to liquid, why does the temperature remain constant even you give the heat to the substance, it remain constant? Why there is no change of temperature when the gas to change to liquid? I know for liquid to gas, you need to the heat energy to break up the bond, right? So let's say from the gas to liquid. So why does the temperature still remain constant even though you give the heat to the substance? Anyone want to try? To overcome the force of attraction. That one is actually to overcome is actually when the heat is absorbed, right? So you absorb the heat to overcome, to break the bond between the molecule. So that's why you need the energy. But for this one, for gas to liquid, right? From the gas to liquid is opposite, right? The heat energy is released to build up the bond between the molecule. Yes, very good. Okay, to create the bond, okay, between the molecules. So for the, let's say from the liquid to gas, okay, so this one, the latent heat of vaporization is absorbed. So the why the absorb is used to break the bond between the molecule, right? But let's say from the gas to liquid, it's actually to form the bond between the molecule. So because you know gas is very the distance is very further, right? So you want to change to liquid, it means you have to move closer to each other, right? So you need to form a bond between them. Okay, So that's why for this one is actually to create a bond, okay, to create a bond between the molecule, because you are changing the phase from gas to liquid. Okay, as you can see, the distance from the for the gas is very further, okay, and you move freely, and now you want to change to liquid. Now it have to move to be much closer to each other, so mean you have to create a bond to them. Okay, so that's why you need to absorb the heat, okay, to release the heat, okay, to create a bond. Okay, so latent heat, this one actually I already explained just now. Anything you want to ask? Okay, so now why the temperature remains constant, right, during a change of phase? Okay, so it depends. Okay, if let's say for the energy, if the heat energy is absorbed, is constant because that energy, heat energy that been supplied is used to break the bond. Okay, so let's say if change from the liquid to gas to liquid, right? So that one is actually to create a bond. Okay, so it depends. Okay, so this one is actually, it said the heat absorbed is used to break up the bonds between the solid molecule, and the kinetic energy of molecule does not increase. Okay, and for this one, when a liquid boils, the heat absorbed is used to, so this one means boiling change from liquid to gas, right? So it's to completely break the bond between particles. Okay, and then the second one, because you know that for liquid change to gas, okay, so the molecule will be released to the surrounding, right? Okay, so it needs the energy, right, to work against the atmospheric pressure. Okay, to work against atmospheric pressure, so it can move freely into the air. Okay, so this one is they have two reasons for the liquid change to gas. The first one, of course, to break the bond so it can move freely as a gas. Okay, and the second one, if they want to move to the surrounding in the air, so they have to overcome the atmospheric pressure. Okay, so that's why they need more heat energy. So if you compare the specific latent heat of vaporization and the specific latent heat of fusion, okay, so the specific latent heat of vaporization need more energy than fusion, okay, because they need to to overcome the two things. The first one, the molecule bond, and the second one, to move freely into the air, they need to overcome the atmospheric pressure. Okay, so this is the graph. I think this is the the heating graph, the heating curve. Okay, so the first one we use the ice. Okay, sometimes they use the naphthalene. Okay, okay, so this is from ice. Okay, and then this is the ice form. Okay, and then it change here, ice to water. Okay, and then it changed to completely to water. Okay, and then this one is the mixture of water and gas, and then after this it changed to the gas. So this is the heating curve. Okay, so for this one, right, so you can see here the temperature is increased. Okay, so if the temperature is increased, where is it, the specific heat capacity or specific latent heat? Which one? There is a change of temperature. So which involve, whether it's specific heat capacity or specific latent heat? Yes, specific heat capacity, because there is a change of temperature, right? If the latent heat, there is no change of temperature, only the change of phase here. Okay, so that's why the heat energy, this one they use the MC theta, right? Because MC theta is actually the formula for the specific heat capacity. Okay, so for the heat energy will be absorbed here, right? And the kinetic energy will increase. Okay, so it will move faster. The molecule will move faster. So what happened to temperature? So the temperature also will be increased. Okay, and then the state of matter, there will be no change. Okay, and the contents here always be solid. Okay, and then let's say it's at 0 degrees Celsius here, right? So let's say this is 0 degrees Celsius here. You know this is a melting point for what for the ice. Okay, so here there is a change of phase here, ice to water. Okay, ice to water, but you can see there is no change of temperature. It will remain 0 degrees Celsius here. Okay, there is no change of temperature here. So there will be remain at 0 degrees Celsius here. So this one is a specific what type of energy involved here? Specific latent heat. Okay, very good. So specific latent heat of what? Yes, of fusion. Okay, so this one, the solid begins to melt. Okay, so M to N solid is melting. Okay, but remember, starting at point N, all the solid already become a liquid. Okay, so from M to N, it start to changing. Okay, from solid to water, and at the point of N is already all of it already melt to water. Okay, so let's say you have a 1 kg of ice, one is already melt to water at 1 kg also. Okay, so for this one, the heat energy, okay, we use the formula Q is equals to ml. So this is the heat energy, the amount of heat energy to change the phase from the ice to water. Okay, so for this time, okay, the kinetic energy constant because all the energy used to change all the energy already used to break the bond. So then there will be no change in kinetic energy. Okay, so for the temperature also constant. All right. And then the state of matter, okay, this one change from ice to water to from solid to liquid. Okay, and the content is solid and liquid. So after that, I already told you at N is already changed to water, right? So for this one, okay, for at this part, okay, at this part, okay, same. Okay, this one is also specific heat capacity because there is a change of temperature here. Okay, all right, for this one, mc theta is absorbed. Okay, and then the kinetic energy increase. Okay, and the temperature also increase, but the state of matter there is no change. It will stay in the liquid form. Okay, and the contents must be in liquid. Okay, and then after that, starting at the OP, okay, so at the boiling point. So at this point, all the water started to change to gas. Okay, so this one we call it as the one is specific latent heat. Okay, so for O, liquid begins to boil. Okay, okay, at the OP, liquid is boiling, and at the point P, all the liquid already changed to gas. Okay, so for this one, the energy, if you want to calculate the amount of energy that changed the water to gas, we use the formula again, Q equals to ml. Okay, and the kinetic energy is constant, means there will be no change. Okay, but the temperature is a constant also. There is no change of temperature here. It will all keep under 100 degrees Celsius. Okay, and the state of matter change, this one is liquid to gas. So at the point P, all of it already changed to gas. Okay, so this is the heating curve. Okay, so yeah, you need to remember. Okay, for this one, what is the type of specific latent heat that we use for water to gas? Yes, latent heat of vaporization. Okay, so this one latent heat of fusion, and this one is the latent heat of vaporization. Okay, so this one is same also like the specific heat capacity, the heat energy is absorbed. Okay, the kinetic energy increase, temperature also increase, but there is no change of state of matter. Okay, and the content is gas. Okay, how about cooling curve? Okay, so let's start from the gas. Okay, so this one, the heat energy is released. Okay, it's opposite than just now. Okay, the heat energy is released. Okay, the kinetic energy is decreased. The temperature also decreased. Okay, and there is no change of state of matter, and the content is gas. So if you want to calculate for this one, we use the mc theta. Okay, so remember if you see a graph, okay, so for this part, you have to know that this one, they have used the specific capacity. So if you want to calculate at this part the quantity of heat of energy you need, so you just use MC theta. But for this one, we use ML. Okay, because there is no change in temperature, this is the latent heat. Okay, gas and water. So you can see the gas begin to condense. Okay, so at QR, okay, the gas condense. Okay, and at point R, okay, here, all the gas already changed to liquid. All right. So if you want to calculate the heat energy that changed from from gas to water, okay, you just use the formula ml here, and the heat energy for this time it will be released. Okay, and the kinetic energy and temperature also will be constant, because all the energy used to form the bond, okay, to change from the gas to liquid, so it need to form the bond so it can move closer to each other. Okay, and the state of matter, no, there is a change of state, right? So gas to water, and the content is gas to liquid. Okay, and then for this one, for water, okay, so the heat energy mc theta release, the kinetic energy decrease. Okay, so this one is a specific heat capacity. Okay, and the temperature decrease. Okay, and the state of matter, right, there is no change, and this one, the content is a liquid form. Okay, for this one, this is a specific latent heat, okay, because there is no change in temperature, okay, but there is a change of phase here, okay, and for this time, the heat energy also released, kinetic energy and temperature constant, so there is a state of matter change here from the liquid to solid, all right, and the content is liquid and solid. Okay, and after this it changed to solid. All right, so this is state of change of solid. So the solid cools down, so the mc theta is released, the kinetic energy decrease, and also same with the temperature, but the state of matter no change, and the content here all is a solid. Okay, so from this part, okay, this is the type of the specific latent heat, is the specific latent heat of vaporization. Okay, and for this type is sufficient. So whether it's a change from water to gas or gas to water, okay, they use the same type of specific latent heat. There is a specific latent heat of vaporization. Okay, so let's say it change from ice to water or water to ice. They use the same amount of energy. That is, we call it as a specific latent heat of fusion. Okay, so that one you need to remember. Okay, so specific latent heat. So just now latent heat. Okay, so it's just same like specific heat capacity and heat capacity. The difference is for the specific capacity they have to constant the mass here, right? They must use the 1 kg of substance. So same like a latent heat also. For latent heat they didn't say the amount of how much is the mass of the substance, but for the specific latent heat there must be the substance must be 1 kg. Okay, must be 1 kg. So the heat absorbed, okay, so they say they ask you the meaning of the specific latent heat. So the amount of energy that needed to change your phase, okay, to change your phase of the 1 kg substance without changing a temperature. So the keyword here is 1 kg, okay, and the change of phase here, and the constant temperature. So then you must have three of these three keywords, okay, to mention the meaning of the latent heat. So let's say they ask you the meaning of the latent heat, so you do need to mention the 1 kg here. So you just say the heat energy required to change a phase, okay, for at the constant temperature. So you don't need to mention the 1 kg. If the specific latent heat, you need to mention 1 kg. Okay. Okay, so let's see if I'm asking you, what does it mean by specific latent heat of fusion? Can you give me the meaning of the specific latent heat of fusion? Vaporization. What is the meaning of the specific latent heat of fusion? Anyone want to give me the meaning? So let's say the question asks, what is the meaning by specific latent heat of fusion? Heat absorbed for 1 kg of substance to change from solid to liquid at the constant temperature. Okay. Specific heat, a specific latent heat of fusion, right? I'm asking for the specific latent heat of fusion. So if I said about specific latent heat, you must mention these three keywords, right? So can you check your answer you give to me whether it has all of this? Did you have the mass of 1 kg? Because I noticed like a few of you didn't mention the 1 kg. Okay, it's okay. So specific latent heat of fusion, you must have 1 kg, right? So you have to check your sentence. Is it have 1 kg? Is it you have to state the change of phase there? And also, did you put the constant temperature? You must have the three change of phase is solid, liquid is and gas, right? Okay. So let me explain. Okay. So let's say they ask you the specific latent heat of fusion, right? So you have to state what is the change of phase there. So fusion is not just solid to liquid, right? It's also liquid to solid. Okay, so you have to mention both of it. Okay, so how you want to mention both of it? So for this one, you cannot say whether the heat energy is released or absorbed because fusion, there is for solid to liquid, yes, the energy is absorbed, but liquid to solid, the energy is released, right? So what I said just now, so you just put your words like this. Okay, so amount of heat energy. Okay, you don't put whether it's released or absorbed unless it said the picture said the solid to liquid. So then you can say the energy is released or absorbed. But for usually for this question, okay, you just put the amount of heat energy, okay, required, okay, to change. Okay, so this is fusion, right? So solid to liquid or vice versa. Okay, for 1 kg of substance without change in temperature. So that's the correct one. Okay, so for fusion, it's not just solid to liquid, it's also liquid to solid. We call it as a specific latent heat of fusion. So when they ask you about the meaning of the specific latent heat of fusion, you have to mention both. So this why I mentioned solid to liquid or vice versa means liquid to solid also. So you must have the 1 kg and also this one is actually without change in temperature means constant temperature. So this is the how you want to give the meaning for the specific latent heat of fusion. So let's say they ask you in exam. Okay, so but let's say they give you a diagram. Okay, so they say based on the diagram, right? Based on the diagram, so the diagram is actually solid to liquid like this one, right? Ice to water. Okay, so for that one, you can say the heat energy absorbed, okay, to change the solid to liquid, okay, for 1 kg substance without change in temperature. Okay, they ask you based on the diagram. But let's say there is no diagram, they just ask you like, just ask you general like that. So you have to answer in these kinds of sentence. You have to mention both of it. Okay, so let's say we try for this one. Okay, for this one is the specific. Let's say I ask you for the specific latent heat of vaporization. So can you write the meaning of the specific latent heat of vaporization? Anyone want to try? Okay, amount of heat energy without the change in temperature. Yes, very good. Heat absorbed for the 1 kg to change. Avinash, you have to mention just now, like I said, liquid to gases to gas or vice versa. Cannot liquid to gas only because liquid to gas and gas to liquid, the same type of specific latent heat, right? Both of it use the vaporization. Okay, Eugene, okay, good. Okay. So Avinash, remember, okay, you have to mention both. Unless the diagram give you, they ask you answer based on the diagram. Okay, very good. Okay, this one because they give the diagram, so you have to use the diagram. Okay, so how you want to calculate the Q is L is equals to Q over ml. So this is the formula actually. Q is the heat, okay, the unit must be in joule. M is the mass, the unit must be in kg. L is the latent heat, the unit is J kg negative 1. Okay. So specific latent heat, there are two types, fission and also vaporization. This one we already discussed, right? Okay, so this one, can you try to answer for me? What does it mean by the specific latent heat of fusion? Okay, but this one, they give you the amount of energy. So you need to state the amount of energy in your sentence. So you just replace, okay, the amount of energy with the energy being given in the question. Okay, so how you want to put in words for this one? Janet, 336,000. Okay, Janet, you don't need to put the unit of kg negative 1 there, okay? So because the energy for unit, the energy unit is 3 joule only, right? So you can leave out kg negative 1. Is required is needed to change 1 kg of ice to water without change in temperature. Okay. Yeah, correct. Okay, for this one, is like we can answer. So it said here 336,000 joule of heat energy is needed to change 1 kg of ice to water without change in temperature. Yes, correct. Because for this one, they already give you the state of the phase, right? State of this phase here, that is a solid. So you don't need to put the vice versa. Okay. So that one is okay. Your answer is correct. We can. Okay. So what's about for the specific latent heat of vaporization? Okay. How do you want to put the meaning for the specific latent heat of vaporization? So this one, they give you already the phase, right, from water to gas. So you don't need to put the vice versa. Just now they didn't give you any like for water or for gas, right? So it means you have to put both. 20,000 amount is needed to change 1 kg. Yes, very good. 1 kg. Yes, very good, Lashmi. Okay, very good, Krisha. Okay, so that's how you want to put in the words, okay, the meanings of the specific latent heat. Okay. Okay, so for this one, okay, actually they say here the specific latent heat of fusion of ice is 3.34 times 10 power of 5. Okay, but this one you don't need to remember. The question we give. Okay, and for the specific latent heat of vaporization is 2.26 times 10 power of 6. Okay, so change here, right? This one is 10 power of 6. Okay, so why the value is different? Okay, like I explained just now, okay, for the fusion, it means from the ice to liquid, right? Sorry, from the solid to liquid. Okay, so there will be like the amount of heat is much smaller. Okay, if you compare to liquid to from liquid to gas, okay, because there are two things, right? For the liquid to gas to change, the first one they need to overcome the molecule bond first. Okay, means you need to break the molecule bond. Okay, and then the second thing, if they want the gas want to move in the surrounding, okay, in the surrounding, they need to overcome the atmospheric pressure. Okay, so that's why for the vaporization is higher than fission. Okay, for because solid and liquid don't need to like to go to the surrounding. They only need to break down the bond. Okay, so only one thing that they need to overcome. But for the vaporization, they need to overcome two things, right? The first thing is the molecule bond. Okay, and then the second thing, they want to move freely in the air. They need to overcome the atmospheric pressure. Okay, so you can move freely. Okay, so this one I already explained. Okay, so this one also I already explained. Okay, so for the exercise here, okay, for the exercise, I want you to do on your own for exercise 1. Okay, and I will discuss, okay, about the application. So for the exercise you do on your own, okay, for tomorrow, and then tomorrow we will discuss, right? And then we go to to gas law, okay, the last subtopic in chapter 4. Okay, so the application for the specific latent heat in daily life. Okay, so that question is your homework, and also I already assigned a homework for you in the GC for this subtopic. Okay, so this one is just to explain how sweating takes away heat from our body. Okay, and how steam can be used for cooking by method of steaming. Okay, and how fish can be kept fresh. Okay, from number 1, okay, explain how drinks can be cooled by adding in several cubes of ice. Okay, so the first one is said here, when ice melt, right, it will absorb a large amount of heat from the drink. Okay, and then it will change phase from solid to liquid, from ice to water. Okay, so when it absorb, okay, the drink will lose heat. Okay, and the temperature will be lower. Okay, so that is how the drink can be cooled down by the specific latent heat of fusion. Okay, so the ice melt because it absorbs the heat from the water. Okay, and then the water will lose the heat. Okay, so it will cool down. Okay, and then for number 2, the freshness of fish and meat can be maintained by placing them in a contact with ice. So this one actually is your homework. Remember, I asked you how you want to keep your drink cool faster, and also how you want to make sure that it can be cool in a longer time, right? So I asked you to do a modification. Okay, so I read some of you when that I already turn into you, so you can check your answer there. Okay, and we discuss on this next Saturday class. Okay, so ice has a larger specific latent heat. Okay, means it can absorb more heat. Okay, so it absorbs large amount of heat from fish as it melts. So the temperature of fish will decrease. Okay, thus the fish can be kept at low temperature for a longer time. Okay, so let's say for the steam. Okay, for the steam means from the liquid to gas, right? So how the steam is used to cook food. Okay, so water has a large specific latent heat. Okay, large specific latent heat means it can absorb more heat. Okay, during this phase, during the changes of phase from liquid to gas. So when the steam condense on the fish, okay, so the specific latent heat is released directly to the fish. Okay, so let's say water. For this time, when you boil the water will change to the water vapor. Okay, then you put the cover here, right? So the cover will change back the gas to the water vapor. Okay, so this change of phase will release the heat, right? From gas to liquid, it will change the it will release the heat, right? So the heat that been released during the phase of change from the gas to liquid, it used to cook the fish here. Then, so at first you put the water here, so the water will be boiled, right? And then when it goes to the cover here, the lid here, so it will change the liquid, right, to the gas. So during liquid to the gas means condensation. So condensation, the heat is released. So the heat they release when the change of phase there is used to cook the food. Okay, so that's why it's able the fish to cook faster. Okay, because of the change from the first one, the water is boiled to change to the gas, and then when it goes to the cover there, okay, there's a lid there, you close the fish, right? So then it will change back the water to they will change back the gas to the water vapor. So the gas change to water vapor, there will be heat release because you need to form the bond there. So the heat released by that is used to cook the fish. All right. Okay, so explain why our bodies feel cold after sweating. Okay, so the sweat on the body evaporates. So it absorbs the specific latent heat of vaporization from the body. So, and then as a result, the body is cooled by the removal of heat. So the sweat of the body will evaporate from the liquid to the gas. Okay, so it will absorb also the same at our heat from the body also, it will be absorbed together. Okay, so as a result, the body is cooled by the removal of the heat. Okay, for number 5, right? Why the burn due to the steam is more serious than burn due to the hot water only? Okay, so water has a specific latent heat of vaporization. Okay, so when the steam condense on the skin, okay, so this one also is same like the one that we cook a fish. Okay, so the steam is condensed, so means from the water vapor, when it touch your skin, it will change to the the gas will change to the water vapor when it touch your skin, right? So there will be large amount of heat is released to the skin. So that's why it can cause serious injuries. This one is also like the one you cook. Okay, you cook the fish just now. Okay, so that is the end of the subtopic today. Do you have any question you want to ask for this subtopic? So are you really clear? Okay. For let's say you do the exercise, okay, can you don't answer if you don't understand? Teacher, I'm not like asking a full set of answer because for me, I like to know what question that you cannot answer. So then I know which part that I need to help you more. Okay, so leave it empty. Don't take your answer. Don't ask your friend. Don't copy your answer from your friend. Okay, so just leave it empty. Then I will help you because we will discuss for every exercise that you do. So it's much better like that. So at the same time, you mean you learn something. Either you take your answer from your friend's answer, or you ask your friend. Sometimes you don't understand because you just copy down. I don't want like that. If you don't know, just leave it. So I know, oh, most of you cannot answer this question. So I can give you more exercise. I can teach you more about that. Can you help teacher by doing that? But don't like giving like empty paper. Teacher, I don't know anything at all. So that don't like that lah. I mean, you can answer like a few questions, one or two of that, and then maybe on the part you don't know, leave it. We will discuss. Alright? Okay? Can you help me by doing that? Okay? Alright. So we see you tomorrow. Okay, so remember, do the exercise in here and also the exercise I send you in Google Classroom. Okay, right, so see you tomorrow. Okay, bye.
Thank you.
Thank you, teacher.
Thank you,
All
teacher.
right, welcome.
Thank you, teacher. Bye, teacher.
Bye.
Yeah,
Yeah.
I sent the table already. You tell me to do
Which one?
for the for chapter 4 one, this chapter.
Yeah, for this
How
chapter,
to
yeah.
modify the drink one.
The how to modify the what?
The drink to
The
be more
drink.
cooler. Yeah.
The drink.
The aluminium one, the aluminium.
You mean the project or what?
It's not a project, that is the homework, the assignment.
The assignment.
Yeah,
The one I gave in GC, is it?
yeah.
Okay. I will see the question, then I will get back to you. I will text you. Is it okay?
Okay.
Okay. Bye.